To solve this definite integral, we first have to find the antiderivative of this integrand. So that is equal to 3 times x to the power of 2 plus 1 divided by 2 plus 1. And now let's define our upper bound, which is 2, and our lower bound, which is 0. And now we can simplify everything. So we have 3 times x to the power of 3 divided by 3. And let's define the bound, so 2 and 0. And you see the 3's cancel out. And now we just plug in the upper bound minus the lower bound. So we have 2 to the power of 3 minus 0 to the power of 3. And this gives us 8. And 8 is our final answer. In our next example, we have the integral from 0 to pi, and the integrand is sine. So let's find the antiderivative of sine x. So the antiderivative of sine x is cosine x, and the bounds are from 0 to pi. And now let's substitute our upper bound minus our lower bound. So this is equal to minus cosine pi minus cosine 0. And now let's evaluate everything. So minus cosine pi is equal to, so this part is equal to 1. And then we have minus, and minus cosine 0 is equal to minus 1. And this gives us 2 as the final answer. In our next example, we have the integral of e to the 2x from bounds 2 to 5. So first, let's find the antiderivative of e to the 2x. And we're going to use u substitution here. So u is going to be equal to 2x, and the derivative of 2x will be equals to 2. And then let's rearrange for everything. So we have du over 2 equals dx. And now let's substitute into our integral. So we have the integral of e to the u, and dx will be replaced with du over 2. So du over 2. And the antiderivative of this is simply e to the u over 2 plus c. And we substitute u for 2x. So we have e to the 2x over 2 plus c. Now let's substitute everything else. So let's define the bounds. So we have e to the 2x over 2. But remember, since this is a definite integral, we don't have to worry about the plus c part. So we have the bounds from 2 to 5. And now let's substitute everything else. So we have the upper bound minus lower bound. So our upper bound, we have 5. So we have e to the 2 times 5 over 2 minus e to the 2 times 2 over 2. And now let me erase everything on the side. And this simplifies to e to the power of 10 over 2 minus e to the power of 4 over 2. And here is our final answer. In our next example, we have the integral of 2x times cosine x squared. So let's use u substitution to find this integral. So we have 2x times cosine x squared. And then now we have to use u substitution. So u will be equal to x squared. And then the derivative of that is equal to 2x. And let's rearrange everything. So we have du over 2x, which is equal to dx. And now let's substitute everything. So we have 2x times cosine u, and a dx will be replaced with du over 2x. And you can see the 2x's cancel out nicely. And the antiderivative of cos u is simply equal to sine u plus c. And then now we substitute the u for x squared. So we have sine x squared plus c. And now let's evaluate our definite integral. So the antiderivative is sine x squared, and our bounds are from 0 to 1. So let's evaluate the upper bound first. So we have sine 1 squared minus sine 0 squared. And this is equal to sine 1 minus 0. So our final answer is simply sine 1. And here is our final answer. In our next example, we have the integral of x times e to the x from 0 to 2. So let's evaluate our antiderivative on the side. So here we have to use integration by parts. So u will be equal to x, and v prime will be equal to e to the x. The derivative of x will be equal to 1, and the antiderivative of e to the x is still e to the x. And now we can use our integration by parts formula. So first we have u times v, so we have x times e to the x minus the integral of u prime times v. So that is simply equal to e to the x. And now let's find the integral of e to the x. So we have x times e to the x minus, and the integral of e to the x is simply e to the x, and our plus c constant. And now we have our antiderivative. We can evaluate our integral bounds. So we have x times e to the x minus e to the x, and we have the bounds from 0 to 2. So now let's evaluate our upper bound first. So we have 2 times e to the power of 2 minus e to the power of 2. And this is our upper bound minus our lower bound. So we have 0, so 0 times e to the power of 0 minus e to the power of 0. And let's evaluate everything. So we have 2 times e to the power of 2 minus e to the power of 2. And that simply gives us e to the power of 2 minus, and then 0 times e to the power of 0 is simply 0. So this is 0. And then e to the power of 0 is simply equal to 1. And this would be our final answer, e to the power of 2 minus 1. If you found this video helpful, please leave a like and subscribe to the channel. And please also comment down what other video ideas and topics you guys would like to see in the future. Thank you very much for watching.